So we have just one more part to our discussion of the completable futures implementation of the ImageStreamGang case study, and this is implementing a StreamOfFuturesCollector and then applying that as we've seen in the previous video. So recall that these futures collectors are used to wrap the allOf method so it becomes a lot easier to work with. And as you can see, the wrapper we're going to use here is going to hide a lot of the nasty low-level details that would otherwise be required if we had to write this code directly in our program. What a mess that would be. So the StreamOfFuturesCollector will convert a stream of completable futures into a single completable future that's going to be triggered when all the completable futures in the stream complete. And StreamOfFuturesCollector is a non-concurrent collector which can be used with both parallel and sequential streams. But as we'll see later when we talk about evaluating all this stuff, it's probably overkill to combine parallel streams and completable futures. That's actually too concurrent, if you can believe that. And the StreamOfFuturesCollector implements the collector interface, as we've talked about before. So remember that a collector is just a way of accumulating the elements in the stream into a so-called mutable result container. And this wraps up some complicated code in a nice, easy to work with encapsulated class that can be used in the context of the streams framework. So here's what StreamOfFuturesCollector looks like. We implement a custom collector. It's going to have a stream of completable futures to elements of type T. We'll have a mutable result container, which will be a list of completable futures to type T. In our case, type T will typically be images by this point. And then the return value of this collector is a completable future to a stream of T. So this is a good example where we can use the finisher method for good purpose. The main way that this implementation of StreamOfFuturesCollector differs from the futures collector we looked at previously is that the stream parameter is used instead of a list parameter. So the previous futures collector had a completable future to a list of T as the return value from finisher, whereas this implementation of StreamOfFuturesCollector has a completable future to a stream of T. You can see here that the factory method is just going to have an array list returned as the type of the accumulator, and that's going to be a list of completable future of type T. The accumulator method, the accumulator factory method, will return the list add method reference, which is a by consumer that's going to be used to add an element of the type T into our mutable result container. Since this is all going to be used as part of a non-concurrent collector, we never have to worry about locks because it's only going to be called in one thread, so there's no issues with the race conditions here. Here's the combiner. This is used for sequential, this is used in the context of parallel streams. We don't use parallel streams, but we have to provide this method anyway because we're making a non-concurrent collector. And what that's going to do is just basically append one list to the end of the other. And again, that's only ever called on a single thread, so we don't need any locks. And here's where things get interesting. This is the finisher method. And this finisher method looks an awful lot like the finisher we used for futures collector, which worked on a list, but this is going to be working on a stream. So that's the main difference. And what it does is it takes the futures, the completable futures list, which is the mutable result container. And the first thing it does is it converts that list into an array and passes it to the allOf method. And allOf will return a completable future, which will be triggered only when all the computations in the parameter passed to it, which are a bunch of completable futures, finish their computations. When that particular completable future triggers, in other words, when all the computations are done, then the then apply completion stage method is called, and that's going to go ahead and take the list of futures, turn it into a stream, and then join all the results. So futures.stream converts the list of completable futures into a stream of futures. We know they are all completed at this point, and so we're going to go ahead and call the join method. This is really just here syntactically to convert the completable future to T, to an instance of T. But the call to join will never block because then apply will never get called. This method here will never get called until the completable future return from allOf has actually completed. And that only gets completed when all the other methods, all the other computations rather, that are running in the background complete. So what we're going to do here is then apply is going to return a completable future to a stream of elements of type T, since there is in fact no terminal operation called after map. So that's the main way that this differs from the futures collector we looked at earlier, which had a terminal operation to collect basically the stream of objects of type T into a list of objects of type T. We don't do that here because we want to have a stream come back when the future is done. And this is how it gets used in our program. You can see how collect returns that completable future, and after everything completes, then apply gets called, and that's going to go ahead and take the stream and then go ahead and apply the flat map method to get rid of everything that's empty. Just to kind of wrap up the discussion of StreamOfFuturesCollector, here's the characteristics. Factor method that just returns a set indicating we don't care what the ordering is because it's all asynchronous, doesn't matter. And we also have the toFuture method, which is the factor method that's used to create an instance of StreamOfFuturesCollector. All right, so that's the end of the discussion of the case study for the completable futures version of ImageStreamGang. It's a bit more complicated to program, as we saw, compared to the parallel streams version, but there will be some significant speed ups in performance, as we'll see when we wrap up our discussion of completable futures in the next lesson.